Hi friends, welcome to this channel. Here we are going to look at today's daily challenge problem. Count the number of good subarrays. In this video, we are going to address this problem using two-pointer sliding window method. So this is a very classic or typical method for solving problems. So we are going to quickly look at the problem statement and then look at example 1, and then we do the coding. And within the coding session, we are going to explain some details. So here we are given an array called nums and an integer key. So we want to return the number of good subarrays of nums. So here a subarray is good if there are at least key pairs of indices, let's say ij, such that they have an order. Let's say I is less than j, right? And then the corresponding values are equal, right? So a subarray is a contiguous non-empty sequence of elements within an array, right? So this is the major problem statement. So here let's look at example 1. So we know in example 1 there are 5 ones, right? So we can pick any 2 indices, right? So in order to consider the number of pairs within the index, for example, if we use this whole array, so let's see how many pairs we have. So we have 5 ones, we can choose 2, any 2 positions. That will be 5 times 4 over 2, right? That is 10. So this is exactly this key, right? So in this problem, so we should return 1, right? So however, if you have a shorter length, for example, length 4, right? So then the number of valid pairs will be less than 10. It's not valid, right? Therefore, for example 1, so the return should be 10. But if we want to count the equal element and then do this combinatoric thing, it does not work. We cannot do computation like this. So how we do the computation? So if we look at the first example, if you look at index 0, so index 0, so you get a 1, right? So you can make a dictionary. Let's say you have a window, right? And then you had 1 appears once. Then at index 1, so again you have a 1, right? So then we know the 2 ones form 1 pair, right? So how many pairs we should get? So the pairs, let's call it count to be 0. So this should be the number of window, the number of ones, right? So this is the 1, right? So we should increment the count by 1. So count equals the previous count plus 1. You get 1. So 1 pair. So at index 2, so you still have 1. Then in this case, the number of new pairs appeared will be again 1. But in this case, you need to update the dictionary to be so 1 appears twice, right? So here window 1 is 2. So the count will be count plus 2. That is 1 plus 2, right? So then you have, so also you need to update the window. So 1 appears 3 times. So then if you do 3, so again you have 1. So now the window at the 1 at the current state is 3. So the count will be count plus 3. That is 1 plus 2 plus 3. So the window will be 1, 4, right? And then at I equals 4, right? So you have 1 again. So window 1 currently is 4, right? So your count will be count plus 4. That is 1 plus 2 plus 3 plus 4, right? So this is 10. This up to now from 0 to 4. So you know this is a valid one. So then if you extend, right? So the index, for example, you can imagine there are some other indices elements as 5 or 6. As long as you include 0 to 4, then you can include all the remaining ones. Therefore, there's 1 valid one, 2 valid one, and 3 valid one, right? Just do some counting. So this also gives us a way to do the computation. Computation in a programmatic way. In a programming, let's say, programming way. So basically, C5, 2, you decompose as, say, 1 plus 2 plus 3 plus 4, right? So that's the way. So now notice that if you, because we are going to use sliding window, so let me first do this. So for each index, let's call it L. So we find the smallest R such that, so let's see, nums from L so to R, both inclusive, so it's good, right? So once this is good, then what you can do, so then any index from R plus 1 up to n minus 1. So you can start from L and ending at this R and R plus 1 and n minus 1. All these are valid ones, because if you fix L and then you can include the elements up to R, so it's already contribute key pairs. And then if you append more elements, you will get more possible pairs, right? So the count will be n minus 1, so minus R, so the big end minus start plus 1, right? So no matter, this formula maybe depends on your indexing, but this is also right, always right. End minus start and plus 1, right? So another thing is that why can we use two-pointer sliding window method? So here is monotonicity, right? So here, if you have L1, so corresponding to R1, right? And then, so you have L2 corresponding to R2. Notice that R is the smallest R, such that this is good if they exist, right? So, and assume L1 is less than L2 because we want to slide L to the right. So then it must have R1 is less than or equal to R2, right? Because if you increase L, and then so the window will contains a smaller thing. It's going to shrink the number of counts, like in this hint, right? When number is moved, then it decreases number of pairs, right? That's why at least you need to have the potential to extend R to, in other words, to include more elements so that you can still maintain the n pairs is greater than or equal to k. So this is actually very important. So now, once you have this, so you already understand this example 1 very well. So we can actually use, after we finish coding, we are going to analyze this one, right? So with that said, let's look at the coding part. So if you could digest the above analysis in a higher level, so writing the code should be straightforward. So we have this nums. So I'm going to initialize a result variable. So this is the counting variable. We are going to return its final state. And then we have a window. Currently, it's an empty dictionary. And then we have count. This counts the number of valid pairs within this window, right? So, and also we set L equals R equals, let me write it like this. It's just to make things clear. So we introduce one more line, right? So some people prefer to write like this. L equals R equals 0, but I want to write like this. So once we have this, so then we do a two-pointer sliding window method. So notice that for two-pointer sliding window method, two formats, as I specified in my previous video. So you can use a double while loop, or you can use a for loop plus a while loop. So the first one is more general, right? So and this one slightly less scoped, depends on the problem statement. So here I'm going to use two while loops. So while L is less than M, then we're going to see if R is less than N and count is less than K. If this was the case, so we're going to include the current in the window. So window. So, but first, so let's see. We included this in the window, but now we haven't updated the dictionary yet because we want to use this computation. when a number is added to the subarray, it increases the number of pairs by its previous appearances. So we want to increment the count within the window. That is, count window. It's possible that the current number does not inside the window yet. So we are going to use this method. So we can call the frequency of the current. If it does not appear in the window, so we'll set it to be 0, right? And then we update the window. So the window current will be the window get the frequency of current and then increment by 1. And then I'm going to increment this R by 1. So it's important to notice the order of these operations. So first we locate this element, and then we do the count, right? And then we update this window. So now you should notice that it's after you update this window, then increment R by 1. So this way, for example 1, so after this while loop, the state of R should be 5, because when you add R equals say here is 3. When R equals 3, you add, this is the 3, right? You add, this is the current status of the, so let's see. If R equals 4, so you add the window, add this 1 into the window, and then you increment R again. So this way you get R equals 5 after the while block. Let me print out this so that you can get this remark. So here, let me just return some 0, right? And increment L by 1 so that I can end this while loop. So you see R is 5, right? So that's correct. So here I want to emphasize it again, right? So each time you can think when R equals 3, right? So when R equals 3, so what do you get? So it might be good to do this one. Print F R equals and the window status, right? So then also I want to just write some I plus 1 to end the loop. So you see. So when R equals 4, right? So because after I add this 1, so then the window is actually up to this status. When R equals 5, actually after this index, this was added. In other words, after we increment this index 4, then this element is added to the window, right? So you need to digest this part. So here, once we got this, so let me check that. So then we need to check if count is greater than or equal to k. Then we know that currently the end, we need to do result increment by end minus start plus 1. So let's identify the end and start. The end will be the n minus 1, right? The start actually should be R minus 1, because after if R equals say 4, so after we add this, we still increment by 1. So this will be R, the current state, so R minus 1, then plus 1. So this is the right indexing. So once you have this, that's good. Otherwise, the count is still less than k, but your R equals n. And actually it's out of bound for sure. So in this case, we just need to break. We don't need to consider further else, right? Otherwise, so what do we do? So then we are going to put the earliest L out the window and then continue, right? So then the window nums L is decremented by 1. Notice that we don't need to do something like this. We can directly call this window with this key, because this is for sure in the window. So once we get this, so the count should be decremented by a window get. So here we need to use get, right? Nums L. It's possible the nums L just appears once before. So here we get 0. Then we push L to the right by 1. Then finally, what we want to do, we just need to return the result. So before we make a further comment or demonstrate example 2, we can first do a run. Yeah, it passes the 2 cases. So now let's submit that. Yeah, it passes all the cases. So now I guess it's time to do a further digest. So here I'm going to do print L, right? So we get L. Then so we get the for each L. So let's see how many the result state. Let's see. Print F result. So then if we do this, so in the first example, for L equals 0, so you get the corresponding result is 1. So when L is larger, so there's no further result updated, so you just get 1. So for case 2, when L equals 0, so you get 2, right? So this, so the 1 pair, right? So up to this one, you have 2 pairs, right? Then you can choose to end at here or end at here. That's why you have 2. So for L equals 1, you get 3 pairs. So here, let's see. L equals 1. So here, let's see. Not you get 3 pairs. You get 1 more pairs, right? So it's incremented. So you get so this provides 1 pair, the 2 2. Then ending at 4, you provide another pair or 4. So then this is the end. You have only 1, right? So when L equals 2, so you get another one. So here actually this one, still 4 4, right? And 2 2, right? And that's the analysis for this one. That's why also you get 4 different subarrays. Here it lists the 4 arrays. So I guess that's it for the coding part. So actually, the last comment is that when you try to use 2-pointer sliding window methods, 2 things you need to pay attention to. The first thing is the format. So you can choose to use while loop, or you can choose to use for loop plus while loop. So here, maybe we can try to write one with a for loop. Let's see. So I'm going to call this one version v1, and then here let's write for L in range n, right? So here I don't need the L plus 1. So let's see if it work, right? Yeah. Good, but sometimes we should try to use this 2 while loops. This is much wider. So this is the one comment. Another comment is that you need to pay attention to the indexing, right? So that's the second one. And lastly, so we have a playlist in our YouTube channel. So there are many 2-pointer sliding window problems, right? So you're welcome to check out the corresponding playlist. With that said, I guess that's it for the current video.